Hello, everybody, and welcome to our second video on what we're studying for the final. This is chapter 9, which is on page 586. So you're all together studying your notes, chapter 6, 7, skip 8, then go to 9 and 10. Those are the 4 chapters that are on this final. So you want to read your notes quietly in a quiet space at home and look at formulas, look at how the problems are worked out, read the boxes, the text boxes have important information, and look at the questions I'm giving you here to see if you remember what to do. So on this page, it's talking about perimeter and area. So I'm going to, by the way, I had to take photos of my book because the internet on the website was down. It's not opening the pages. So I have to resort to this. So this looks a little bit different. Plus you'll see my notes I made myself. Before I give a lesson, I usually make notes. So you're going to do number 1. So sir, this is the page 586. On the left margin, you have formulas and review. The perimeter, capital P, of a polygon is the sum of the lengths of its sides. Circles have a circumference, capital C. The area, capital A, of a polygon or a circle is the number of square units it encloses. And then it gives you the formula. So you want to probably put these on your, this is a simple one, a square, side length squared, a rectangle. The ones you know, you don't need to put on a flashcard. It's the ones you can't remember. So anyways, this is a nice thing to look at. And then perimeter. Oh, and then it gives you an example. Yeah, so you can look at the quick review and the example, and then you're going to do these exercises that I circled, number 1, number 3, and number 4. This is the circle in terms of pi. So your answer will have pi in the answer. Or you're going to use 3.14 on your calculator if it's an approximation. So this is exact. If you use 3.14, it's an approximation. So you're looking for area versus circumference. Okay, so top of the page, we're going to the bottom. Now we're talking about parallelograms. The area of a parallelogram, base times height. The base and the height are always perpendicular. They have to be at a right angle. So these two are not the height. So you're not counting these unless it's something that looks like, no, in a parallelogram, the height would not be a leg. Well, no. Excuse me. Then it gives you an example and you're going to do, oh, in a triangle, base times height divided by 2. This is the one I prefer. Same thing. So you're going to do number 5, number 6, yeah, do 7. Because the height is on the outside here, which is sometimes happening if it's an obtuse triangle. So then you have to extend a leg, but the leg starts here, from here to here, but the height is on the outside. It's still 6 times 10 divided by 2. See if you can figure out what that is. And then, so that's that page. Then we are on the next page. Now we're talking about trapezoids, trapezoids, rhombuses, and kites. Those formulas get a little tricky, so you think about which ones you need to remember that you need to write on a flashcard. So for a trapezoid, You have two bases that are parallel and you need to add those first. So that's, I like this formula better. You add the bases, then you multiply by the height, and then you divide your answer by 2. That's how I have shown it to you. This is the same. Okay. Again, the height and the bases are perpendicular. Then we have a rhombus. So you have diagonals and you need to multiply those and divide your answer by 2. That's this formula, or diagonal times diagonal divided by 2. That's a rhombus or a kite. Both of those have that formula. But remember, sometimes they're only giving you, on this case, the diagonals are equal. If it's a rhombus, the diagonal, I shouldn't say they are, the two parts here are equal. Like this is equal to that, and this is equal to that. So if they give you one part, let's say this is 5, you have to do it twice. So that would be another 5. So that would make the one diagonal 10. And if this part, let's say, is 2, and this part is 2, you have to add those 2 to get the total. So that would make it 4. And then you would multiply those numbers and divide by 2. I'm just showing you another example. So that's a rhombus or a kite. And then we have an example how to find the area of a trapezoid. And then you're going to come over here for the exercises. You're going to do number 10, 12, and you need to do those on paper. And if you want the points for it, you have to show them to me or text or email them to me. I prefer a good email, actually, because remember last time the computers were down, the internet was down, and I couldn't give you your grades, and I forgot who showed me what. So now I have to do it again. So now if you email me your photos and there are good photos, I give you credit. Make sure you write what the assignment was in the subject line. Okay, so look at, this is what I'm talking about. See how they're giving you half of the diameter? I mean, yeah. So you need to find these two, you need to find the total. So you add them. So this would be 18 and this would be 13. So you multiply those numbers and don't forget to divide your answer by 2. This one is a little tricky. I know that some of you can figure it out because, well, actually it's not. There's one that I like that's a little tricky. And I put it on the final, I think, because I thought, well, somebody will figure it out. It's one where you have to use the Pythagorean theorem. I'm not sure. Nope, not on that one. Because you can do this one 12.8 and this is 10. So that's not a big trick. You notice that the diagonals always meet at a right angle. So if you have one right angle, all 4 are right angles. That's a property, a rule. And then this is a challenge one. A trapezoid has a height of 6. The length of one base is 3 times the length of the other base. The sum of the base length is 18. What is the area? I thought somebody will figure it out. Somebody that loves math will sink their teeth into it and figure that out. Okay. Then we have coordinate geometry. Anytime you see a chord plane, you have coordinate geometry. And I only threw this one in there because there's a question on the final where you have to find the perimeter of this triangle. So it's not the question, is it scalene, isosceles, or equilateral? I don't think that's on the final, but don't get me. I don't want to put my, but it could be, but I don't remember it on the final, but I know this is on the final. So what you have to do is you have to count the legs and then find the hypotenuse using Pythagorean theorem, and then add up all 3 sides. So Yeah, this is a way to do it using the distance formula, which we never went over. I always showed you the Pythagorean theorem. The distance formula is derived from the Pythagorean theorem, but I think it's good to know using this right here. So, but if you have 2 points in the coordinate plane and you want to know the distance between the 2 points, let's say you have a point here and a point here. I'm just making it so, and you want to know how far it is. You cannot use a measuring stick. You need to use math, algebra. So what you want to do is you build a right triangle. The legs have to be horizontal and vertical, where you can count the units. This is 3 and this is 4. And then write 3 squared plus 4 squared is the hypotenuse squared. And solve that. This is how you do it. 9 plus 16. 9 plus 16 is 25. And take the square root at the end. Use your calculator. So 5. And the perimeter would be 12. Okay, so I actually showed it to you. This one you could not, because see how the lines, the legs are, you could not do this, what I showed you here. This one won't work because you have no vertical and horizontal legs. So you would not be able to find the missing length or any of these lengths unless you use a right triangle on each one of them. So let's say you want to find this length, you have to build a right triangle like that. And then do what I just showed you. (16 plus 4 is 20. And then the square root of 20 is a irrational number. It'll be about 4.5 maybe. So then you can find this leg, and then you would do the same with this one. You'd always build a right triangle to find the sides. And you'd have to do that 3 times, and then you'd have each leg the length, and then you could find the perimeter. But without those right triangles, you cannot use the Pythagorean theorem. So I'm not giving you this one. I thought I'd give you this one since we already have the right triangle to look at. And then we're gonna, I gave you graph paper, remember in class? I'm gonna have you try number 20. This, we're not gonna do the classification. You can if you want. But we're going to, well, I guess that's what I had in mind. Sorry about that. Yes, you do need the classification, which means name it. What kind of shape is it? So classification means what kind of shape is it? So you have, in this case, it's asking scalene, isosceles, equilateral. This is a right triangle. They don't even give you that option. It's a right triangle. This one is scalene because all the angles are less than 90 degrees, unless this is a 90-degree angle. It's hard to tell. Looks more like scalene. So try number 20, graph your points in a coordinate plane, and then look what kind of shape it is. So that's that. And then I think we're going to chapter 10. So chapter 10 review pages start. I have to find it. Page 646. And we did not do everything in chapter 10, so you're not going to study 646. So I'm going to tell you what to cross out. You're not doing 10.1. You are going to do 10.2, which is where we looked for patterns. Find a pattern. right? Describe the pattern and use it to show the next two terms. So you're going to do number 7 and 8. And here it gives you an example. Use inductive reasoning when you make conclusions based on patterns you observe. A conjecture is a conclusion you reach using inductive reasoning. That's kind of like logic. A counterexample is an example that shows a conjecture is incorrect. So if you can show one example that a conjecture is false, then the whole conjecture is false. All it needs is one counterexample. And then it gives you an example here, and then you're going to try number 7 and 8. Okay. Then we're skipping the next. We're going straight to 10.6. So I'm skipping a lot. So we did some proof. We started on some proof. Use deductive reasoning and properties. Remember those rules we went over: reflexive, addition, subtraction property, symmetric property. Look at those again on those pages in that lesson. It's 10.6. You want to read the lesson again. A proof is a convincing argument that uses deductive reasoning or logic. A two-column proof lists each statement on the left and justification on the right. Remember, statements, reasons. We've done that. And then it's asking you here for the example and its transitive property. If the angle A is congruent to angle B and angle B is congruent to a third angle C, therefore the first and the last have to be congruent as well. It's transitive. You're kind of skipping the middle. Yeah. All right, let's try. So remember up here, we have not studied this, so don't worry about it. Fill in the reason that justified each step. So this is a good example of segments. We got QR, and I don't see the last letter here. Maybe I can look at it in my book. QR and S is the last. So remember, the sum of the parts is equal to the whole. That's probably not going to be used. However, that's what I'm talking about. You got this part plus this part is equal to the total. Given QS is 42. Yep, it's going to be in there. So the whole thing is 42. So I like to mark that. From here to here is 42. So the two parts, this segment plus this segment is equal to the total. That's where my equation comes from. This part plus this part equals 42. Notice it's right here. X plus 3 plus 2x is 42. And so the first step, QS is 42, is given. I'm going to do this with you. QR plus RS is QS. That's called the sum of the parts is equal. I'm just going to get that started. The sum of the parts is equal to the total. And I'm going to go dot, dot, dot. It doesn't fit here, but this is exactly what that is. QR plus, sum means plus, RS is equal to QS. Maybe there's a better property name for it, which I don't know. Maybe there is one and I'm not mentioning it to you. I'm not aware of it. I always call it the sum of the parts is equal to the total. And then we're substituting because we have QR plus RS is QS, but QR is X plus 3 and RS is 2X. So I can substitute it. And then we have 3x plus 3 is 42. So what happened? We have 1x plus 2x. That's called combining like terms, which I tell you guys sometimes when I walk around looking at you solving equations. That's something a lot of you do not do correctly, or you forget. You always want to combine your like terms before you move on so that it's shorter. Then we subtract 3. subtraction property. And then we have divide by 3, division property. I'll just make it short, division property, and then that's it. We're done. X is 13. That's what we're supposed to prove. So if you can follow step by step, we should actually do this before you learn how to solve equations, because solving equations requires all these steps, and a lot of you want to skip that. You want to go from here to here, and that's not what it's about. It's about following, being able to look at each step and see what happened. And then the last page I have for you is up here. This one is definitely on the final, this question, so check it out. A statement that you prove true is a theorem. A proof written as a paragraph is a paragraph proof. That's kind of when you talk about it. In geometry, each statement in a proof is justified by given information, a property or rule, a postulate, which is an unproven statement, a definition, or a theorem. And there you are, you got a paragraph proof. See how it's written like a paragraph? So you kind of lay it out like you would talk about it. 1 and 4 are congruent because it's given. 1 and 2 are congruent because they're vertical angles, these two. 4 and 2 are congruent because it's transitive. If 1 is congruent to 4 and 1 is congruent also to 2, that means 2 and 4 must be congruent. And then it moves on. 4 is congruent to 3. 4 and 3 are also vertical angles. And then again, transitive property. Therefore, 2 and 3 must be congruent as well. It's kind of a logic thing behind it. If you want to check it out, if you want to study that, look at it again. If not, if it went right over your head, don't worry about it. We can't learn everything at once, right? So now look, what I want you to look at is these two angles are vertical angles and they're always equal. So the equal part is where, if you can write down an equation like this and realize that one angle, do you see that little angle, is equal to the other angle, you already earned some points in my book. Now, if you can't solve that equation, it doesn't mean you failed totally, but you already have realized that the equation is set up correctly. But you should be able to solve it. 20. 5 minus 3 is 2y. Add 16. 36. Divide by 2. 18. Find the value of y, 18. So this definitely you need to be able to figure out. Okay, and now it's asking find the measure angle. This is your angle symbol, AEC. AEC, this angle, we want to know how big it is. 3 times 18, y is 18, plus 20. So 3 times 18, I believe, is 54. 3 times 18, 54 plus 20 is 74. And then, of course, this one is 74 as well, because they're equal. 5 times 18 minus 16. So if you do that in your calculator, it should end up being 74. 5 times 18 minus 16. Yeah, 74. So measure number 33. Measure angle BED. BED, 74 as well. They're vertical angles. Measure, I want you, the reason I'm going over the symbol, you got the symbol triangle and you got the symbol angle. So you want to keep those separate. This is not a triangle. This is an angle. Measure angle AEB. AEB. So now we're looking for this angle. So this one was 74. So this is called a linear pair. What's the sum? If they're forming a straight line, which these do, these two angles here, this one and this one form a straight line, their sum is 180. So now you can figure out that 180 take away 74 leaves you with 106 degrees, I believe. Yeah. All right. So I think that's pretty much it. Is there anything else on this page? No. So again, you're studying in your notebook chapter 6, 7, 9, and 10, 4 chapters. Look at your notes, make one flashcard, only the front, because if you pack too much stuff on it, you'll be counting on that flashcard too much. I want you to count on your study skills, count on studying, and then when you're done studying, which parts do you not remember for sure? Those go on a flashcard. Not everything you think you'll need to know. Totally wrong. Okay. All righty, guys. And another good trick, when you make your flashcard, have several flashcards. The first one, you can put a bunch of stuff on there. Then you study those. You try to memorize the formulas that you put on. Once you have it in your head, the formula, take it off and start a new flashcard, and eventually you'll have less and less information. You only want to have on your flashcard the information you definitely will not remember because you've tried. But whatever you can remember, take it off your flashcard, and in the end, your flashcard should be pretty empty. Maybe 1 or 2 things that you really can't remember. Okay? Okay, good luck, guys. And we're going to go over some of these questions on Thursday.